Isn't there like a file header for PE files? Yeah, there's definitely a file header for PE files. Hi folks, and welcome to Open Analysis Live, or rather a Twitch clip from our Twitch stream. We're streaming Thursdays and Sundays. Go check us out if you like this kind of stuff. And also a reminder that we have over 200 hours of live stream recordings on our Patreon, as well as in-depth reverse engineering tutorials. If you like this kind of stuff, go check it out. Now let's get back to the clip. Okay, all right. Yeah, what's the explanation here? I can show you in a hex editor. Let me open up our two instances in the samples here. 9. There we go. So let's open up this guy. And let's open up this guy. All right. So let's look at .NET Magician. Yeah, exactly. Yeah. Okay, so let's look at the unfixed one first. Okay, so everyone knows, does everyone know? In a PE file, you have your section table. Like, Sergey, how are you like the Matrix? You can see that's the section table? No, I have no special powers. I can just see that there's .text, .r data, and .p data. I wouldn't be able to parse the section table off by heart, but that's why we have tools like PEBear. So let me load these up in PEBear. By the way, this exact discussion is going to be on Patreon in about a week because I get asked about it so often. Okay, so thankfully, we have tools like PEBear, which will parse the section headers for us, and it'll show us in a nice little format here. Now, we want to look at this one first. Which one do we want to look at first? This one. Yeah, we want to look at this one first. So, this is what a normal section table looks like. You have, for each section in the PE file, you have what's called a raw address. And this is actually just the offset in the file where the section starts. You also have what's called a virtual address. It's not really a virtual address, it's a relative virtual address. And where this is, what this is where in memory the section is going to be loaded. Sections are not the same at the same place on disk and in memory. And actually this process of taking a PE file from disk and loading it into memory so it can be run as a process is called mapping the file, right? And that's the job of the Windows loader, is to map the file into memory. Of course, you guys see, if you watch any amount of OALabs streams, you've seen me reverse engineer mini malware mappers before, right? You see them always grabbing each section and moving it into memory. We've looked at these many times on stream. So, what do I mean by a bad PE file or a bad dump? Well, if you are dumping malware from memory, it's in its mapped format. You don't really have an option of dumping it in the unmapped format because you're dumping it from memory, meaning that it is mapped in memory. We're not going to talk about PE files that are in memory, like on the heap or something like that. We're just talking about they're in memory because they're part of a process. So if you dump a process and you don't use a unmapping tool like Scila or like PE Unmapper or something like that, you're just going to get a copy of the memory. And what that means is that these raw addresses are no longer going to make any sense. They're not going to line up with the sections because the sections are now located at the virtual addresses. So this is why you saw me just a minute ago copy the virtual address to the raw address. This is what we call like a janky unmapper, or as it used to be called, the Franken unmapper, where I used to work, where you don't actually unmap the binary, you just trick the section table into thinking that the mapped binary is identical to the unmapped binary. So you basically destroy the section table and make it look the same as the map binary. Now, what happens is people often dump memory with what they think is a PE file in it, and they don't unmap it or fix the section table, and then they slam it into UNPACME. They're like, have have a look at this malware, bro. I dumped from memory. And then we have this this situation where it's technically an invalid P file. Like if you tried to run it, it wouldn't run. It's broken, but it looks like a P file. So what we have to do is we kind of, if we're writing a config extractor, we have to kind of keep this in mind and be like, all right, let's try and handle scenarios where the P file is a little messed up. So what I did was I just wrote a small piece of code here. Where is it? Yeah, there we go. So I wrote a small piece of code and I checked to see whether the section table, whether the raw offsets in the section table point to junk data. Of course, your first section in the P file is a code section. That's where your code is located under most normal circumstances. So if the section, that first section starts with 100 null bytes, you might be dealing with something that's fucked up. So this is just a janky, really shitty check. It's not generic. It's not going to work generically. But because we know the type of file we're going to be extracting the config from, we know that file doesn't start with 100 bytes at the text section, right? So you can't use this generically. You have to use other methods, which I'm not going to talk about on stream because they're part of our product. But you can use this shitty method if you know the file doesn't start with a bunch of null bytes. And if it does start with a bunch of null bytes, then you know you have a messed up version of the P file. And to fix this, what I did was, instead of using the native P function or P file function to get the section data, which relies on the raw addresses, I used this unmapping technique where you use the virtual address, but you treat it as if it's a raw address. So you see, I was actually just pulling it directly from the file. And if that's still a little bit unclear, let me show you in hex editor, which I think makes it the most clear. So here's your PE file, here's your section table, and if we look at PEBARE, we look at the original file, it tells us that 400 hex is the beginning of the first section. So let's take a look at 400 hex. The fuck? Ain't no section, bro. It's just a whole bunch of null bytes, right? So you can tell right away just by looking in the hex editor with no real, you don't have to be studying the PE file format to see that something is wrong here. If PEBARE is telling you that first section starts at 400 hex and ain't nothing at 400 hex but a bunch of null bytes, right? Now let's look at our unmapped sample. Our unmapped sample, we have now copied the virtual address to the raw address. So that first section is going to start at 1000 hex. Let's go take a look at our unmapped version. 1000 hex. We have a nice bunch of stuff in there. And you'll note between that first section and the end of the headers, it's all null bytes. So that in a nutshell is what's going on. And that little fancy magic of copying the virtual address to the raw address is what I'm doing here programmatically. So hopefully that explains it. And like I said, I'll have a more in-depth version of that up on Patreon. I'm actually working on that right now. Later on, probably not this week, it'll be next week sometime. But yeah, hopefully that explains it. Hopefully that clarifies it. And again, you don't have to know anything really about the PE file format to notice in a hex editor that a bunch of null bytes are where the first section is supposed to be, right? You don't have to have any sort of, that's not hard to do. So you'll probably see me sometimes on stream open shit in a hex editor if things are going wrong. I don't understand what's going on. Usually it's a good idea just to kind of take a look at the format here and see what's going on. It's kind of cool because once you know that you have null padding between the sections, you could say scroll down here and be like, oh, that's probably the end of one of the sections because look at all these null bytes. What's that? I have no idea. Look, there's the beginning of another section. Does that make sense? 4,000 hex. Let's go look here. Hey, that's another section, 4,000 hex. Right? Kind of cool, right, guys? All right, I hope you guys enjoyed that. Just a reminder that we are live on Thursdays and Sundays on Twitch. And if you like this kind of stuff, go check out our Patreon. We have lots more reverse engineering content, over 200 hours of live streams, as well as in-depth reverse engineering tutorials. All right, until next time, keep exposing the mechanics behind the malware. Stay curious.